Okay, this video is to demonstrate how to use the Lily collector and MOOSES for Windows to collect data and do some simple analysis on the data using a code as it happens real-time coding scheme. I'm assuming you're going to go into a classroom or some other setting and do recording of a student or whatever your participant may be. So for this, I've already made a couple of coding schemes for people, and I'm going to use Nina Weisling's coding scheme and Ma's coding scheme just to give you a look at a couple of them. But we are just going to look at real-time code as it happens for this video. So first I'm going to set up Lily collector to collect a little data with Nina's Weisling's setup. So I'm going to launch the program. You'll notice I have this timer box. I want to get out of the way. I want to make the window a little bigger, and I don't have her codes loaded, so I'm going to go change preferences. I'm going to pick her code file, and it's on my desktop in the folder that I showed you, and it's named Nina. I hope it's Nina and not Nina. If it's Nina, then I'm going to say it wrong the whole time. Okay, so there's our Lily coding scheme that I've made, and I usually make code files for people to get started and just send them to you, and I'll be sending these out to the people who are using them, and I'm going to say open. For this, we're using just event mode, so that's what we want that set on. The observe and record duration are not relevant, but a number does have to be in there, or it won't save anything. It doesn't know that blank is something. But they're not used for this type of coding scheme, and the reset intervals or codes to off is not used. If a note here, if you think that things are going to happen really fast, it's nice to do times in milliseconds, but for this demo I'm going to just do it. Times are regular seconds. It'll just be easier to read that way. And I'm going to look at the screen tab. I think it's probably okay. The timer box is up to you. Personally, I don't like it, but a lot of people do, so I'm going to leave it on. And we're not going to do anything with multiple participants. What that would do is add a number to your codes depending on which participants you're watching, and that's a big hassle. But it will do that, and I'll cover that in a later video. So it should be set. I'm going to close it. It will change to her coding scheme. And it's not fitting very well, it looks like, on my screen here. But I don't have to scroll, but just for the sake of argument, I'm going to make the buttons a little bit wider and a little bit thinner. So I'm going to send this down to about 40, and now I'm going to send this up to, for this coding scheme, 160, 170, because we have more width than we have height on this. Close it. It's going to adjust things, and that looks better to me, so that's the way I'm going to leave it. So then you'll note here that if I just exit, Lily will keep the settings. So I'm going to launch it again. Kept the settings. I'm going to adjust my screen a little bit so I can see everything. And then the procedure will be start a new file. It says down here on the bottom status bar what you should do. Open a new file. New file. And I'm going to save it in Nina's folder. Actually, I don't think I'll make a new folder called data. Put it in there. I'm going to put name. You need to come up with this coding file name scheme that tells everything about your subject, and hopefully comes up with names that don't repeat themselves, so you'll know from the file name what's in it. But for this, I'm going to say demo 1.eve. And EVE is a nice extension to use for this. And I see a bug there I need to fix. Header line. Now this can be anything. You can put anything in here you want. It by default puts the date and time in the header line of the file. And this just goes into the top of the file. Say OK. Then it says set the initial state and start the timer. You know what this set the initial state is about is set what's going on in the scene before you start. So let's say that our student is doing independent work and he's on task active and there's no interaction going on, and that's how it is right now. And then we're going to start the timer using the timer start box. Now you can set a start time if two people are watching and your clocks are synced. It will start them at the same time, which is a nice feature that customer suggested, and I loved it. So I'm going to click start.
Begin observation session now.
I got a begin prompt on the mic, and I'm just going to pretend that things happen. Consequent happened. Student volunteered. Called on the teacher. Called on the teacher. Teacher told him to redirected him. Redirect. Redirect. Okay, something on there. Need to make it a little wider because what's happening there is those are wrapping, but we won't worry about that right now. And let's say comes teacher plus academic interaction going on. And then say a peer positive academic action starts, and then there's no interaction again. And let's say changes to whole group. The teacher gives him a praise, gives him another praise. He volunteers. Teacher expands on the response. Calls on the teacher, asks a question, teacher answers the question, and so on. And for the sake of time, I'm going to stop this session early. So I'm going to say stop, and then I'm going to save and close. And then I'm just going to close Lily and let you see what it did. So if I open this folder, and I open the data folder that I made, and then there's demo1 EVE. Now I double click it, and I've told my machine that I want EVEs to be opened by Notepad. So if I double click it, it opens it in Notepad, and you'll see codes with time marks in there. I'm just going to pretend that we went to 600 seconds and nothing changed, which is not true, but I'm going to put 600 as the end time. But this is just to show you that you can edit things. And I was pressing buttons really fast, and I don't really like it that things happen in the same second. So it would be nice if it was going on that fast that I would be using milliseconds, but I'm not. So I'm just going to doctor this up a little bit. But the point being is you can edit these things. You don't want to, mess up reality for yourself. 8, 9. This isn't really going to work out for me, is it? 4. Let's say it's 42. 43. 45. And this data doesn't really matter because it's just play data, but you could put fixes in here with the fix button. There's a fix button on the screen, and that would show you where to edit. And the way we normally use a fix is, whoops, I hit the wrong code, I hit fix, and then I hit the right code. And let's say that happened, then you would just make the wrong code the right code and change the time so that it matched. But basically, this is the time that you hit that code, and this is the code itself in the beginning. So I'm going to save that. And I also want to fudge some data for doing a little bit of reliability, so I'm going to make a copy of this file. And I'm going to call this demo1 rely. And then I'm going to monkey with it to mess up a few things to make sure that I get a few disagreements in here. 24. Don't really remember what these codes mean, but 73 there. And let's say this one went to 153. Let's say this one went to 129. That'll give us a little bit of disagreement in the files to look at. And I'm going to save that and close it. So just wanted to demonstrate that you can easily edit these with Notepad, and while you don't want to bend reality and you don't want people editing each other's files and making a match, you don't want that kind of thing, but you do want to be able to fix things when they're not really right, and you know they're not really right, so you keep a notepad or you hit the fix button to tell you when to fix things. And that's just going to happen in a real-time system no matter what. So just wanted to demonstrate that you can edit these, and it's fine to do that. Okay, then I'm going to jump into MOOSES to do some analysis on these two files that I just made. So I'm going to run MOOSES. Should have sent you a download link to that, and you would go into the activation. I should have sent you an activation code and activate it so that everything will work. In demo mode, a few things don't work, but it works enough for you to play with it. So this is the new MOOSES screen. The idea is this light blue teal area is what we're going to do stuff to. The darker teal greenish area is where we're going to put the output, and then the brown area is what we're going to do to the data file. So that's the idea. First thing we want to do is set some preferences, especially for the code file. So I'm going to go into the code file editor, and I'm going to load up the matching code file that goes with Nina's data set, which is on my desktop, and it's in Nina's folder, and it's the one with MV4 on it for MOOSES version 4. And these are her codes. And they have groups, and groups are described here, the frequency codes. And notice we just want to count those, but we have duration states for these other code groups. So we want to know how long those last, but for the frequency codes we're just going to count those, and those are group 0. Sampling we will need to set for all these, and it's just going to be time dependent for all of them. I should have said this earlier, sorry. I will send you that file. It just means it's an event with a time with it, as opposed to an interval code or a toggle code. Shouldn't take but a second. And if you just close the file, it'll save. I'm going to be sure and say exit saving file. There is an exit no save, but if you just close the file, it will save it. Verify that by just opening it again, and yeah, the settings are still there. Okay. Now, to get files into the area where you want to, the files that you want to do analysis on, says drag files to analyze here. Well, I go out to Windows, I get those couple of files I collected, and you can do a whole bunch of them. And I just drag them into the white space, just like that. And you see they show up there, and if you don't want them, you can just, whoops, remove that one. And then I'm going to put it back. Whoops. Remove this. You don't want to nest things like that, so I'm going to do this. That's what we want. The idea is you could do a bunch of pools, but we're not going to go into that today, and most people don't do that, really, to be honest. And then you can save this file set as a set. So I'm going to save this as a file set so that I don't have to do that dragging in business again next time. I'm going to put it in data. So say demo set. It's just a set of files that are linked into a pool by this list. Now notice pooling is adding up over sessions, so we're not going to do the pooled output on these right now. But the next thing we need to do is create an output file where the data is going to go, and it's still in the data folder. And that's fine, so I'm going to put demo output, and you can name these however you want to. But notice it tells you where it's going to go, what the name of the file is. I'm going to say don't include pool, and just going to look at the rest of the preferences real quick. Now, this is the input file type, which is correct for this. If you're using Procoder, you would use different. If you're using interval files, you'd set that. But each of the analysis has its own settings. And first one we're going to look at is frequency and duration, and you can nest those counts, but we're not going to do that today either. But so the settings are right for that. We're going to look at the settings for inter-observer agreement, and they look right for that. Non-exhaustive is what you would use for frequency codes. And we're going to display some disagreements, and we're going to look at this agreement matrix. And we're going to set our agreement window size to 3 seconds, and that's only used in non-exhaustive. That's described in Yoder's book, but I'll show you when the output comes out. And we're not going to deal with any of these other analysis today, but this should get you going. So I'm going to save the settings. For first thing, I'm just going to say test read, just to make sure it reads the files. If I run that, it opens a file with the output file, and it says test read. The test read worked. There was no errors. If you leave fixes in there and they're not in your that word is not in your code file, which is the way you should do it, then it'll tell you the way you didn't fix something, so you go back and edit the file. But we want to make sure the test read works, and then we're going to go down to event frequencies and durations, and then I'm going to run that. And I want you to notice that the test read stuff is still there. So what it's doing is building a file of things. And these frequency codes, it told me how many I had and the percentages of the total that is. And you can group them different if you would want your student codes. We could put a different group here and get that as a different percentages. And then on task active was 100% of the time. No interaction was 97% of the time. And that's the first file. On task active 100% of the time in the second file. Then in the 97% of the time in no interaction. Those look the same. This is slightly off because I changed one of those codes, if you'll remember. So 73. Basically, this is frequency counts and durations for those two files. Now, normally you're going to do a bunch of files and want to put them in a spreadsheet, so I'm going to tell it that if you check output as comma separated file, it will do that. But we're not going to go over that today either. I want to do an inter-observer agreement, and then I will stop. To do an inter-observer agreement, you want your files matched, so you want them to be paired up one after another. And these are, but if you pull them in, you have to pull them in pairs. So I'm going to run that analysis, and this is where my disagreements are, which is a very useful thing to have. It tells me the time of the first file and the second file where my disagreements came out at. And you can look at this in Procoder if you have it on tape, or in a comma separated file. You can print this out and look at it. Say, we disagreed on this code. This is a new feature in this MOOSES. I'm just going to continue to the report. And again, I still have the test read on top, frequencies and durations for both files. And if I checked pooled, I'd get pooled. This is my big, huge agreement matrix for all my frequency codes. And that's almost so hard you can't read it. Let's see. I can get it to. I'm going to tell it to not wrap so that it looks a little prettier. But basically that says you both said TA in the same time window twice. You said TE in the same time window once. Anything off the diagonal is a disagreement. Let's see if we can find one of those. Here's one where the first person didn't say anything when the second person said SN. So, and this TF with the first person said TF and the second person didn't say anything in that group inside that window. The new non-exhaustive agreement matrix report takes a little explaining, and I can do that later if you are curious. This is saying that, notice we get 601 in all these. That's because of the 0-second counts, and I didn't know what to do, but so we usually get 1 more second than we need. I didn't change anything in the student interaction state in that group when I monkeyed with the files. So we got total agreement there. Both people were saying NA, which is I forget, but anyway, both people were saying NA for 585 seconds, and both people were saying TA for 10 seconds, so we have 100% agreement there. Here we got a little bit off. We got 3 seconds off where the first person said I when the second person said W. 3. So we have a little bit less agreement there. That's how to look at that. And just to show you one more thing, if I clear the output file and just run this again, then I will go ahead and continue, but I only get the agreement report because the rest of it got cleared. So you might want to do that instead of building a big long output file. And I think I'm going to stop for now, and that should get you going on how to collect. And well, hold on, wait a minute. I think what I'll do is I have a couple of files for Maha's set, so I'm going to set MOOSES up for that. I'm going to go to the code file editor, open her code file. It's on my desktop. Maha. There's her code file. It's a little bit different. Still have groups. Count. We have some on off. duration, off task. We have a few other different things here. But that sets that. And I'm going to make a new output file in MOOSES folder. So say demo output. And I'm going to remove these and put some of her data in here that I did some test events already, and I called them text. So test event. And calling them text is okay too, .txt, and that's actually nice because Windows shows it to you right there. So same thing, I'm going to clear the output file just to make sure it's clear, and if it's not been created, it is clear. It says I can't find it. And then I'm going to run some frequencies and duration just to show that. Here's some counts. And here's other counts. And I'm going to run an inter-observer agreement just to show that. And there's her disagreements. Continue through that. Oh, what happened? I didn't close it. Clear the output file. Run this again. Continue. I don't know what happened. Should be working. Sometimes when things don't work, I start the program over and it works. So let's try that. And then I'll hopefully get these bugs fixed. Test events, text. Test events for LaText. Yeah, it works. So something didn't get set right in between changing code files. Anyway, same kind of thing. You have agreements, disagreements. And just to demonstrate that, there's an on-off task code that I monkeyed with. And this means that the first person had on task, which is 2A, for 74 seconds when the second person had off task. So that's how you would look at disagreements there. In the non-exhaustive, you have this none category that comes into play. So that's just to show you that it does other coding schemes as well, and I'm going to stop here and make this a movie, and hopefully it will get you guys going on how to use this thing. And I'll do further movies about other things later. Thanks, and see you on the internet.